Welcome to Algebra 1 and the first of many videos that you will encounter this year. We're going to start at the beginning in section 1.1 where we look at evaluating expressions. So first of all, what is an expression? Well, an expression is going to contain variables, so let's take a look at what a variable is. A variable is a letter used to represent one or more numbers, and those numbers are the values of the variable. Of course, x will probably be the most common variable that you'll see, but it could be any letter. Now, an expression is a combination of numbers, variables, and operations. So we're going to look at some of those operations as well. And then we can further specify an algebraic or variable expression. And this is an expression that contains at least one variable. So if you were to look at, say, a simple expression such as 4 plus 3, that's an expression. An algebraic expression would be something like x plus 3. It contains at least one variable. Very often you'll see more, but for now let's just look at one. Okay, now in order to evaluate an expression, first of all, if you have a variable, substitute a number for each variable. And typically, to begin with, you'll be told what number to substitute, and in some cases you'll need to try to solve for that number. Then perform the operation or operations in the expression, and then finally simplify if necessary, and very often this will occur with fractions, for example. So let's look at an example here. So evaluate x plus 4 when x equals 6. So first of all, substitute the value that we were told in place of the variable. So substitute 6 for x plus 4 then becomes 6 plus 4. Then perform the operation. In this case, we only have the one operation, addition, so we perform that. 6 plus 4 equals 10. Now simplify if necessary. Well, of course, we don't need to simplify this any further. We already have our answer of 10. So here's some examples of some very basic common operations. Addition, so y plus 9 would be an example of that. Subtraction, z minus 5. Multiplication, notice that we at this point do not want to write 3x7 to represent 3 times 7. We do have some options though. We have the dot, 3 dot 7 means 3 times 7. Computer notation will use an asterisk, so you could see 3 asterisk 7, or you could use parentheses to show multiplication. In the case of a variable, when we have multiplication by a variable, we can show that multiplication with a dot, or even if we wanted parentheses or an asterisk, or more often you'll see simply 2r with no multiplication indicated. So if you see a number next to a variable with no operation indicated, it is multiplication. Then division we can show with the divide sign, 8 divided by 2, or we can use slash. Again, this would be common computer notation, or a fraction. Fraction bars show division. So 8 over 2 is the same thing as 8 divided by 2. And by the way, there's a case where you would need to do some simplifying, right, if you got that answer. Okay, let's also look at exponents here, which you've hopefully encountered before. So a power is an expression that indicates a number multiplied by itself repeatedly. So it's shorthand for showing multiplication when we're multiplying the same number over and over and over again. And a power consists of a base and an exponent. So if we were to look at here, our base is 5, exponent is 3, and we want to write that power in words and as a product. So in words we would say 5 to the third power. We could also say 5 cubed. So by the way, and you've probably seen this before, but if you see 5 to the second power, we often say 5 squared. As a matter of fact, we typically would say that. Oops, 5 squared. And 5 to the third power, we might say 5 cubed. Any power higher than 3, we typically just say to the power of. So 5 to the fourth, we would just say 5 to the fourth power. Okay, now written out as a product, we go ahead and write 5 3 times. Notice there are not 3 multiplications, there are 2 multiplications. So the number of multiplications will always be one less than the exponent when we're looking at positive powers. So if you had 5 to the 10th power, you would have 10 fives, 9 multiplications. Okay, just something to keep in mind. So as mentioned, 5 is the base, 3 is the exponent. All right, let's look at a few examples here. So evaluate each expression when x is equal to 4. So we're going to substitute 4 in place of x for each of these. So instead of writing x plus 5, we write 4 plus 5. We perform that operation and get 9, and we're done. In the second case, when we have subtraction, substitute 4 again in place of x, subtract 3, and we get an answer of 1. Substitute 4 in place of x, and we can write 7 times 4, and this is equal to 28. And then division, we can write as 4 over 2. Now you could simplify right away to 2 over 1, or you could just look and say, oh, I already know that 4 divided by 2 is 2, and we have our answer already simplified. Okay, and one little quick word problem. This will be about the shortest word problem that you'll ever see. And the problem says on a certain day you have 30 minutes worth of math homework and 40 minutes worth of science homework to do. Write an expression to show the total amount of homework for that day and calculate that total amount. So the first step is to write an expression. So we want to take this and convert from words to an expression. So we could say something like 30 plus 40. So the key here is to recognize that you need to add those two amounts together, which should be pretty much common sense in this particular case, and then calculate that total amount. We apply that operation, the addition, add those together, and we get 70. And of course, if we're really being picky, we should say that's 30 minutes plus 40 minutes is equal to 70 minutes. All right, so there you go with evaluating expressions, and have fun with this section. Enjoy.